We are trying to solve a dosing problem. Let's take a moment to read the problem. A client is ordered 2 milligrams of morphine IV push post-op cesarean section. Morphine is packaged in a 5 milligram per milliliter Tubex. How many milliliters of morphine should be given? When we're doing a dosing problem, we want to start by looking for the ordered amount and the available concentration of the medication. In our problem, the ordered amount is the 2 milligrams. The available concentration is the 5 milligrams per milliliter. When we go to solve the problem, there are 3 different methods that can be used. We can use dimensional analysis, which solves all dosing problems. We can use the nursing formula, which is perfect for this type of dosing problem when the medication is given at one moment in time rather than per hour. We can also use a proportion, which is 2 equal fractions. Again, a proportion is perfect for this type of problem that is given at one moment in time rather than per hour. I'll start with dimensional analysis and then go through the other methods as well. In the dimensional analysis approach, we always start with what is ordered. In this case, 2 milligrams. We'll put that over 1 as a placeholder in the dimensional analysis strategy. In dimensional analysis, we need to multiply by a fractional conversion. In this case, the strength of the medication. So we have 5 milligrams available in 1 milliliter. I put the milligrams on the bottom so that it cancels the milligrams from the order. I have my answer with a label of milliliters because it is the only remaining label. On my calculator, I'll take 2 divided by 5, which is 0.4 milliliters, and I have solved the problem. In the nursing formula, the D stands for the desired amount or the doctor's order. In this case, the doctor's order is 2 milligrams, so I substitute that into the formula for D. The H stands for what I have or what is on hand. The label of H needs to match the label of D, so I have 5 milligrams. And the labels match and cancel. The Q stands for the quantity. The 5 milligrams is in the quantity of 1 milliliter. The quantity gives us the label for our answer because it is not a canceled label. So on my calculator, I take 2 divided by 5 times 1, and I have my answer of 0.4 mLs. The proportion method uses equal fractions. So I start with the order of 2 milligrams, and I put it over X milliliters because I want to change it into milliliters. I put an equal sign denoting that I will make this equal to another fraction. The fraction that I make it equal to is what's available. There are 5 milligrams per 1 milliliter. Notice that in the proportion method, both fractions have milligrams over milliliters. The fractions match in their labels. When I solve a proportion, I use the cross product, so I multiply diagonally. On my first diagonal, I get 2 from 2 times 1. I don't put a label into this part of the problem. On my other diagonal, I get 5x. Now I have to divide because division is the opposite of multiplication and allows me to isolate my variable. And from the division, I get x is equal to 0.4. When I go back and look at my setup, the x was with the label of milliliters, so the label of my answer is milliliters.